All right, guys, so, let's see, let's do a short little review of some stuff. It's hella warm in here, huh?
Yeah.
Damn, okay, we might need 2 breaks today. It's too hot. All right, guys, so, let's see, so we'll do a quick little review with the unit circle stuff, just to remind you, I know it's been a week. Trig functions. And today we're gonna focus on special angle. So let me go back to last week's notes, just to remind you of a couple things. We talked about radians, what radians are, how there are different ways of measuring angles. And then we talked about the connection with the unit circle and the trig functions that we defined. I also want to remind you guys that this is not a trig class, it's a pre-calc class, so I'm only going to cover the very trig concepts that you'll need for calculus. That's why the days are scheduled where like the sections are a little wonky. Like they don't go in order, because we don't have time to cover all trig. That's what you did in the trig. Okay? Okay, so let's just remind ourselves of a couple things. So we have a circle here. What's the radius of that circle? 1, which is why it's called the unit circle. Right, so it goes up to 1. What's the equation of the unit circle that we've been using? X squared plus equals 1 squared, the radius, but in this case, that's just 1. That's the equation of the circle. And then the way we define it is we have what's called standard position. Your radius here starts at the positive x-axis, and then it rotates by a particular angle, which we're calling theta. And then on this unit circle, we looked at on Desmos, we looked at the coordinates of the points of this circle. It has coordinates x, y. And then we introduced it with some history behind it. But then when we used it to define the trig function, what we were saying is the x coordinate on the unit circle gives us what we're calling the cosine of our angle theta. Okay. So as I move this angle around, what's the biggest x value that you can get on the unit circle? 1. And what's the smallest one? Sorry, not smallest. The most negative one, I guess? Negative 1. And so it turns out that we know that this has to be in between. Cosine has to be in between positive and negative. Okay? We defined the y coordinate to be the sine of that angle. And the same thing, as I move this around, the y coordinate could be as big as 1 or as negative as negative. Taylor's circumference. Okay. And then we use this to then define all the other functions. I'm not going to write them all down. Doesn't take too long. But that's kind of where we started. Maybe let's write down tangent. Y over x. This distance here is x. This distance here is y. So the interpretation that I was telling you about tangent was you can think of it as the slope of the radius. The slope of the radius. And when you do tangent of an angle, it's giving you the slope of the radius depending where it's located.
So is that gonna be the same as like S over R, or would it be R over X? We're like finding the sector. Or is it unrelated?
Are you saying like the area of the sector?
Yeah.
It's different. Different, yeah, it's different. Yeah, because this is talking about slope, not area.
Okay.
Of the radius. Okay. So we use this unit circle to help us define these trig functions and then the reciprocals of them. But now what I want to focus on is on the special angles that you probably were exposed to in your trig class. Cover those real quick. These are the angles that you're going to see a lot in your calculus classes. So we're going to start first with the multiples of pi over 2, which remember pi over 2 corresponds to how many degrees? 90 degrees. And so what do I mean by multiples of pi over 2? Well, what's 0 times pi over 2? 0. What's 1 pi over 2 times pi over 2? Pi over 2. What's 2 times pi over 2? 2 pi over 2, but it's really going to be reduced to pi. And then 3 times pi over 2 over 2. And then 4 pi over 2 becomes 2 pi, and you cancel 2 pi. That's if you start rotating in the counterclockwise direction. Pi over 2, pi, 3 pi over 2, and then 2 pi. But then you can also go backwards in the clockwise direction. So we multiply pi over 2 times -1. Negative pi over 2, multiply by -2, you get negative pi. Multiply by -3, you get -3 pi over 2. Multiply by -4, minus 2 pi. And so on. And then this just keeps going. Okay, so these are multiples of pi over 2. And so let's take a look. I'm going to hopefully make what makes it hard to evaluate trig functions at these special angles is knowing where they're at on the unit circle. Okay, because once you know where they're at, it'll be very helpful. So let's do a little circle here. How did that one look? Pretty good. Okay. So because these are all technically multiples of 90, and we're on the unit circle, what are the coordinates of the points here on the unit circle? It has radius 1. What are the coordinates here? 1, 0, right? And then you rotate 90 degrees or pi over 2, then you end up with this terminal point. What are the coordinates of that one? 0, and then the y value is 1. Then that's this guy here. Then you rotate another pi over 2 radians, takes you to pi. What are the coordinates there? -1. Then you rotate another pi over 2, that takes you to 3 pi over 2. And then you end up with -1. And then you rotate another pi over 2, takes you to 2 pi. You end up at this point, and then you just keep repeating this. Or if you did it in the negative direction, it would still always end up at one of these 4 points. Okay. So therefore, if on the homework, I'm asked to figure out what sine of 11 pi over 2, okay, without a calculator, you're going to use the fact that on the unit circle, sine is going to be the y coordinate of the point where your radius rotates. But you need to know where it rotated so that it rotates 11 pi over 2. Okay? So you're always going to start in your standard position here in the positive x-axis. Is it positive or negative? Positive. So we're going to rotate counterclockwise. And because these are multiples of pi, this is a multiple of pi over 2, rotates in those multiples 11 times. So you go 1 pi over 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you end up right there. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
So is that what, like the 700 degrees one?
That'll be, if you wanted to turn it to degrees, that's fine. But the reason radians are used on the unit circle is because basically you break this unit circle into fractions. And then you just move according to those fractions to get you where you need to be.
So if it were asking you to move like pi/3, would you just go like 60 degrees at a time?
We'll get to that one. Yeah, but yes, you would. Okay, so then if I end up here, what is the y coordinates of the terminal? -1, and by definition, that's what the sign is supposed to be. It's supposed to equal that y coordinate. So this should be -1.
So it's one per quadrant. I kind of thought it was one per like two because it's 180. It's like,
No, yeah, so what happens is on the unit circle. Right? Pi doesn't correspond to a whole circle. It corresponds to half of the circle. So what's happening is that pi/2, you're dividing pi into 2. And so that's why it
yeah.
turns out, yeah, you don't break up the whole circle into a half, you break up half of the circle into a half.
Gotcha.
Yeah, good question. So, real quick, before we move on, I just want to make sure that you know that you on your calculator know how you would plug this in. Just to check. So can I have you guys, whatever calculator you plan to use? One, confirm that your calculator is not in degree mode, but it's in radian mode. If you don't know what that means, let me know. I'll go around and help you.
Now, are we allowed to use graphing calculators on this test?
Definitely not.
Okay.
No.
Considering I could download like apps. Or you have to turn it on. No, we, do this. What?
It was so close. You have like corny in place. You know? At least one of us wants to. It's better on that. I suppose. It's point, it's at least close. If it was good, how we have me. Hey, I used to know how to do it. Like, I used all the points in like 3 sections and I did terribly. And then minutes, yeah, that's how it is. I don't know. It was hard though.
All right, guys. So yes, please be aware of that. It's basically your calculator is probably on degree mode.
Oh, you have to change it.
So you have to change it, and that's why it's going to take time to figure out how to do that. Oh, right there. Yeah.
Oh, mode. Do you have mode on it?
Mine's up here.
Do you have mode on it?
Oh, it's
It's that one. And then,
Oh, there you go. You change it to
yeah.
that. Okay,
there a pie button.
there should be a pi button. It might have you do like shift and then hit the pi.
Sure.
Oh, yeah, it is.
That one. Right there.
Yeah.
Oh, cool. Okay, guys, so just to confirm, right? Okay, so let's see, let me have you guys try one real quick. Try to do secant of -5 pi. Do it without a calculator. And then check with your calculator.
When you went, oh no, the graph, was it like 11 times?
It was 11 multiples of pi over two,
Oh, okay,
not 11
Yeah.
full circles.
okay.
So this means you need to go,
5 times multiple pi.
actually, hold on, let's do this one together. It's a little confusing. So this one says 11 pi over two, right? So you can see that it's 11 times pi over two. But this one is not 5, it's not 5 times pi over two. Because then that would be 5 pi over two. Okay? So in this case, you can think of 5 multiples of pi. Pi is 80 degrees, 180 degrees. So I would go, let me draw a circle here. Negative pi would go this way, negative 180. That's negative pi. So you're gonna do that 5. This one here is not, it's not that. It's not 5 pi over 2. It's negative 5 pi. So you're gonna go negative 1 pi, negative 2 pi, negative 3 pi, negative 4 pi, 5, right there. So you end up right there. Okay? So just be careful with that.
But you do secant on the calculator?
Well, what's the secant equal to?
1 over cosine.
It's
Oh,
equal
so
to
it's the
1
inverse of-
over, not the inverse of cosine, it's a reciprocal. We're gonna get into inverses later. So if you can figure out this guy. Right, we know we end up here, so this has a terminal point right there. How can this point help you figure this out?
You plug in cosine.
The cosine is supposed to be the x coordinate. What is the x coordinate of this point here on the unit circle? Negative 1. So it'd be 1 over negative 1, which is negative 1. Okay? Yeah. Do you have a question?
Oh, yeah, so it doesn't matter if it's X or Y for,
It does matter because cosine it is supposed to give
Oh,
you the
right.
x coordinate. It equals the x coordinate on the unit.
which one's the third one again? The tan, which one's like,
That's the ratio
Oh.
of y over x. That's the ratio of y over x.
that's the, like the angle, right?
That,
Slope,
this,
yeah.
Yes, like,
the slope, it represents, visually, it would represent the slope of the radius depending where it ends up at. Okay. Okay. Well, you guys are gonna get more chances to do one, but. So there's multiples of pi over 2. Let's get to the nastier ones. It's gonna be multiples of pi over 4. So let's do this again. 0 times pi over 4, 0. 1 pi over 4, pi over 4. 2 times pi over 4,
3 pi over 4.
which reduces to
Two.
pi over 2. Then 3 times pi over 4, 4, and then 4 times pi over 4, pi. And then we just keep going from there, doing the same thing. And then the same thing in the negative direction. Negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi, and so on. Here, you guys are really going to see the fraction thing that I was talking about. Okay. 180 degrees is equal to pi radians, okay? But this says that you're splitting up pi into fourths. So think of it like this. You got pi and you're splitting up into 1, 2, 3, 4. You guys see the 4 slices of pizza there? Okay, those 4 slices correspond to these 4 angles. Okay, here's pi over 4. Here's pi over 2. Here's 3 pi over 4. And then here's pi, which is 4 pi's over 4. Okay. And then you just keep going. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and then the bottom gets split up into fourths as well. How many pi's over 4 so far? 5 pi over 4. 6 pi over 4 reduces to
5,
over 2.
7 times.
7 pi over 4. And then finally,
5,
8 pi over 4s, which is again just 2 pi.
We ever get to like 5,
5 pi over 4?
like large, no, just like 5, like large numbers, like.
Yeah.
Oh, yeah.
Yes, guys. Okay, but now here, let's see, how are we gonna figure out, here we knew these points because they're on the unit circle, they have radius 1, so we know what they should be, right? But like, for example, this guy here. How do we know what coordinates those are gonna be? Okay, all right, but let's see why. Let's do a quick review of why that happens. Okay, so you got this guy over here. Let me see if I can draw it a little bit better. Where's my black marker? Oh, I'm carrying it. My bad. All right, so when you're at this angle here, at pi over 4, as we did last week, we get a little right triangle from this radius here. And on this angle, right here, okay, the slope of this radius is going to end up being 1 because the side of this triangle will be the same length as the side of this triangle. How do I know that? Well, let's see. How much did we rotate this guy here?
45.
45, which is pi over 4, right? This is 90. From geometry, the sum of the angles in a triangle have to add up to 180. So you got 45 plus 90 is 135. So then whatever this angle is, it has to add up to 180 eventually. 180 minus 135 turns out to also be 45. So since both of these are 45, the sides across from them must be of equal length. Okay, and so in that case, when we go back to this, if they're of equal length, what does that mean about the x's and the y's?
They're the same.
They're exactly the same. So on this point here, the x coordinate and the y coordinate will be the same. Whoops. They're going to be the same. X will equal y here. And so if I wanted to figure out, well, what would be the x coordinate? I would use my unit circle. And so from the unit circle, I know the equation has to look like this, but for this special point at pi over 4, y equals the x. So I can just rewrite the y as the x. Does that kind of make sense? Okay. Do a little bit of algebra. What does the left side become? Equals 1. Let's solve for x. Divide by 2. We get x squared equals 1/2. And then finally, we're going to root it. It's hella hot. Okay, we took the square root. So what must happen when you take the square root? You end up getting plus or minus 1, the square root of 1, which is 1, over the square root of 2. But we got to rationalize. So then we multiply top and bottom by root 2. Plus or minus root 2 over the square root of 4, which is just 2. And that's where the root 2 over 2 came from all those little geometry facts. Okay. But plus or minus because it depends on the quadrant that you're at. See here on the first quadrant, the x coordinate is positive, but the x coordinate on the second quadrant would be negative. So you're gonna have to be careful, it'll depend on the quadrant, yeah.
Why do we leave it at root two over two instead of like using our calculator and doing it?
Because this is the exact value,
Oh, that's true.
yeah, versus use a calculator, you're approximating, you're like rounding it up.
Remind me again why you did, I know the root two comes from root two cancels out the roots and comes two, which is 4. How did you notice something by that two? You got rid of the,
So you end up with basically the 2 and the 2 end up multiplying together,
okay, oh, square root 4.
square root of 4. That's what that comes from, yeah. What does this tell us? That means that in all these, this one, except the pi's over 2's, the ones that we already dealt with. But on these ones here, 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 and here, the coordinates will either be root 2 over 2, and they'll alter on sign depending on where they're at. Okay? So let's try one real quick, and then I'll have you guys try one. Okay, let's say I'm asked to find cosine of 5 pi over 4. Well, on my unit circle, I'm gonna go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So I'm right here. So what are gonna be my coordinates here? First off, what's the sign of the coordinates? They're both negative. So they're both gonna be negative, negative, root 2 over 2. Okay? Negative root 2 over 2, negative root 2 over 2. So what's cosine of that angle? That's right. Cosine is the x coordinate. The x coordinate is negative root 2 over 2. So negative root 2 over 2. Okay? Question? Sure.
I was just. Going to say.
Oh, okay. Little bit of vocab that you probably learned in your trig class. See, this rotation here is 5 pi over 4, right? But in your trig class, you guys learned, you called this angle a special angle. That one was called a reference angle. Okay? How many radians is that reference angle if you're rotating 5 pi over 2? 5 pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and then you rotated another pi over 4. So this little angle here. So let me write that here. This is what we're going to call the reference angle. So the reference angle of theta, in this case, theta was 5 pi over 4. The reference angle of theta is the acute angle. What did acute angle mean? Lesser than 90 degrees. Is the acute angle formed by the x-axis and the terminal side of theta, which is where basically where the radius ends up. So the radius and the x-axis, that's what's called the referencing. Okay. Let's talk about this little guy right there. All right, let me have you guys do one real quick. And then we're gonna take a like 5-minute breather. This is really hot. Where am I tripping? It's not that hot? Okay. I think I'm moving around. Right? Okay, all right. I get so excited. Okay, so let me have you guys work this bad boy out. Tangent of negative 3 pi over 4. Remember how we define tangent in the unit circle. First locate where negative 3.4 will be. Remember, you're going negative, so you're going clockwise. Check with your classmates.
I remember doing that. I used to have a thing in my head, right? I remember.
We have an index card.
We gotta remember.
All right, guys, let's see. So remember, you always start at 0, angle 0, okay? So angle 0, how many multiples of 3 pi over 4? 1, 2, 3 pi over 4, negative 3 pi over 4. So you rotate it this way, which essentially is exactly this location as well. Okay? And so they have the same coordinates since they end up in the same location. And so tangent would be y over x. Yeah. Which event, yeah, it'll end up being 1. So that's the y coordinate divided by the x coordinate, which is exactly the same thing. So you end up with 1. And notice that means the slope of the radius is up 1 over, because it has the same values here. Question.
And this only holds true at the over 4, right?
This will, what will only hold true at the
Like
level?
it'll be 1 and there'll be those numbers.
Yeah, exactly. Here, exactly. Here, these are going to be the same thing. So it'll be slope 1, but here, the signs will be different. So it'll be slope -1 and negative. Yeah. All right. All right, guys. Our last one will be the multiples of pi over 6.
What about pi over 3?
We are gonna see it also include pi over 3. Yeah, kind of the way that pi over 2 includes the multiples of pi. Similar kind of thing. See, hopefully I have enough room. The multiples of pi over 6. So same thing, 0. And then we got 1 times pi over 6. And then 2 times pi over 6 will give you 2 pi over 6 reduces to pi over 3. Okay, pi over 3. And then you got 3 pi over 6 reduces to 3/6 is really a half pi over 2. Okay? Pi half. And then you keep doing it. Then 4 pi over 6 and then 5 and so, okay? Same thing that we've been doing and the same thing in the negative direction. That pattern continues. But now let me draw a bigger unit circle because we're gonna need to do this more. All right, so your pi, your 180 degrees, got split up into how many parts? 6 parts. So the top part of the circle is going to be split up into 6 pizza slices. Okay. So 1 pi over 6. I'm gonna do right here, 1 pi over 6. 2 pi over 6 is really going to be pi over 3. 3 pi over 6 turns out to be right here, pi over 2. And then 4 pi over 6, 5 pi over 6, 6 pi over 6. You see that? Okay. And then you just keep going. 7 pi over 6, 8 pi over 6, and so on. Okay. Now let's bring up a little bit of geometry again to explain how the coordinates are going to look. Pi over 6 is how many degrees?
30.
Gonna be, let's say you forgot how to do that, you multiply it by 180 over pi. Pi's cancel, 180 divided by 6. It's 30, so it's 30 degrees, so. This is really 30 degrees. So as kind of how we did it over here, we're gonna bring in triangles to help us out. So we want to figure out what are the coordinates of these points right here. Okay. This time, instead of drawing a triangle straight down here, because we know this is really 30 right here, 30 degrees. If I draw the same 30, but in the negative direction, this vertical will go like that. So if this is 30, what is the whole thing here? 60. Okay. And what turns out to happen is that this will give you an equilateral triangle. So it's going to be 60, 60, and 60. Okay. Now, how long is the radius of the unit circle? 1. Right? So because you have 60, 60, and 60 here, the equilateral triangle, all the sides will be equal. So this will also be 1, but it's also the radius. And then therefore, this will also be 1. But if this is all 1 right here, this splits it in half. Something called an angle bisector. Okay? Splits it in half, so that this will be half the length, which will be 1/2. So then you have this triangle like this. You got your 30, you got your 60 from being an equilateral triangle. This is 1, this is 1/2. So we need to figure out what this guy would be. Okay. We use Pythagorean theorem. Give this a letter. Let's call it A. So with Pythagorean theorem, we have a squared plus b squared, which in this case is 1/2 squared, equals c squared, which is 1. Okay. So you got a squared plus 1/4 is equal to 1. Can you guys see back there? Yeah. Let me move it over here. So then subtract 1/4 to both sides. That becomes, what is it? 4 3/4. So then as before, we square root both sides. And we end up with the square root of 3 over 2, but I square rooted to get plus or minus. Okay. And so notice that this triangle, this small one here, tells me that this length is gonna be √3/2, which corresponds to the x coordinate. And this height of 1/2 corresponds to the y coordinate. Okay. For this bad boy, pi/6, pi over 3 is how many angles? How many degrees? What is it? 60, right? So this guy's 60 degrees right here. And so for this guy, if I draw this triangle going down here, imagine this triangle. It looks like this now. So I got 60 here, so that's this angle, 60. 90, and then this will be 30 again. Okay, so it would be the same thing. The hypotenuse will still be 1. The shorter side is gonna be 1/2. And then the longer side is √3/2. Okay. So now the shorter side corresponds to the x coordinate. It's gonna be 1/2, and then the longer side corresponds to the y coordinate. √3/2. Okay, so they flip. And so for these special angles right here, this is like hella not symmetrical, but it should be. Let me do it more symmetrical. This should look more like this. Okay. For these guys, the pi/2s, that's these ones, that's these points that you use. For the pi/6s, notice that this will have the same reference angle. It has a reference angle of pi/6. So if you go directly across, what would be the coordinates at this point? It should be the same distance, the x distance and the same y distance. It's just once this time x is going to be negative. Well, what about y? Still the same. Okay. I'm running out of room, so I'm gonna have to erase this one. And then there's a little fun little figure here that summarizes all this stuff. Let me show it to you. So we summarize all of this with the following diagram. Maybe you've seen it, maybe you have not seen it. So we have a big old unit circle here. Okay. You're going to have your 60 degrees, which is your your 30 degrees, which is pi/6. Your pi/4. Your pi/3. And then you got your pi/2. And there's this beautiful pattern that emerges with the coordinates of these special points. Okay. Let's see. And this is what the pattern will look like. So for the x coordinate, what's going to be the x coordinate here? Right on the unit circle. 0. 0,1, right? But I'm going to write it this way so you guys can see it. Look. √0/2. Then here it goes to √1/2. And then √2/2. √3/2. √4/2. And let's double check. What's the square root of 0? 0. 0 divided by 2? Still 0. So it's still technically correct. Okay. What's the square root of 1? 1. So this really is 1/2, which is this guy. Okay. √2/2. That one stays √2/2, which is the the coordinates here for your pi/4. Then you got your root 3/2, which is the one we just found. And then you got, what's the square root of 4? 2 divided by 2 is 1. So that works with the x coordinate. For the y coordinate, you just do the same thing backwards. Root 0/2, root 1/2, root 2/2, root 3/2, and then root 4/2. So you just simplify. As long as you simplify it, you'll get the right coordinates. So it's a kind of like little helpful diagram that summarizes what all these points coordinates will be.
And it works like that.
And then it works like that, the whole circle. It just depends on the signs, correct? Signs.
Why root 0/2?
Which one?
Why root 0/2?
This is root 0/2 is really just 0/2, which is really just 0.
Why are we writing it that way? Just to make it look similar?
It's like a way to remember, like a little device to help you remember these points. Yeah. You don't have to use it. I'm just showing you that. This summarizes all these points that we just discussed in this nice little fancy way. So it's a nice pattern basically that shows it. Okay. All right, so let me leave this here. And then I'm gonna have you guys, I don't want to erase this, hold on. Yeah. All right, I'm gonna erase part of this, okay? Leave this stuff here. And then I just want to spend some class time, then we'll take a break. Let's see, so for your practice. Some of you guys might be faster than others, so help your classmates out. So evaluate all 6 trig functions at theta. Do it where theta will be -9 pi/4. And then theta will equal 11 pi/6. So all 6 of them, sine, cosine, tangent, secant, cosecant, cotangent. They get cut off. Oh, they get cut off. Let me show this part of the video for that. Yeah, here's the whole board. So it looks like that. Yeah. Yeah. I do without a calculator, guys. Looks like some folks are not sure where to start. Remember, just draw a unit circle and locate where negative pi/4 will be. And where would this angle be? If you're looking at multiples of pi/4. If you guys are doing that, I'm going to file a buildings and grounds request. So that we can get. So if we can eat in here. So. All right, real quick, can I just have you guys confirm with your classmates the right position of 9 pi/4? Let me just do a quick little check just to make sure, because if you're not getting that part, then it'll be,
Yeah.
you won't get the right answer.
I'm like.
It's negative, so it could be.
Yeah, it's negative.
Yeah.
Put it in the negative four.
Oh, I think it's.
What's that? No, it should be in this fourth. It goes around.
Oh, it goes around one.
Yeah, I think it's a whole different problem, so.
So they're saying it's negative, so we don't start on the right side. Or you always start on the right side.
Down. Oh, it's negative. Oh, that is so
-9. I know the heat is like, making you not see it, sorry.
It's negative one, two,
That one, so what's that one then?
Why is
Well, let's see, where did your angle end up? How did you get there? Walk me through what you did.
Well, I try to go around.
Mhm.
9.
1 times.
Wait. What the hell?
Well, no, so it's, first you gotta realize that it's higher than 4, right? So what you wanna think of is, you're gonna divide pi into 4 parts. So 1, 2, 3, 4, and then the bottom, 1, 2, 3, 4. Because it's negative, you gotta rotate clockwise.
Okay.
So each of these is a pi over 4 rotation. So 1,
2, 3, 4, 5, 6.
so you're right there. Yeah, so you start by first figuring out that you're dividing pi into 4.
And then if it's like out of their six, then you divide it
Into 6 pieces. Yeah, you would go 1, 2, 3, 4, 5, 6.
Okay, that makes sense.
Yeah, only got -2, -2, sign. Repeat the -1, basically was 2, negative. Oh, I see. I forgot that. Where's this? 3/2, those figures. Yeah, eventually with a positive.
Two different ways. One is like, if I went off of this, I know that the x has the 1/2 for the pi over 3 angle.
All right.
And pi over 6 has √3/2. The other way of thinking about it is 1/2 is √1/2, right? And √3/2. This is bigger. This number is a bigger value. So for example, if I'm looking for cosine of, let's say, pi over 3, there's this angle here. So if I drop this little triangle here, the x value is this long versus here, the x value is longer. So this angle should have the smaller of these two. All right, guys, I'm gonna put the solutions here. You can check it and reference it. Let's see, so. Got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Should end up right here. Oops, so hard. They're supposed to be, that's why I emailed the college right now. All right, guys, let's see. So if you do sine of your theta, cosine of your theta, tangent of your theta. For sine, so you split up your pi's into 4s. You would end up with 1, 2, 3, 4, 5, 6, 7, 8, 9. And so your reference, what's your reference angle here? 45 or pi over 4. So we're gonna have the √2/2 coordinates, but in this case, the y coordinate is negative. And so x would be positive. So let's see, this is supposed to be the y coordinate. Negative √2/2. This is the x coordinate. √2/2. And then your tangent will be y over x, which is going to be negative. And then you got your reciprocals. Cosecant of this angle, the reciprocal of this guy. Yeah, need some space. -2√2, but you can't have a square root at the bottom, or you want to rationalize it. So you end up with -2√2/2, which is really -√2. Okay. Does that look right?
Yeah.
Yeah.
Okay. Secant of theta is the exact same thing, but in this case it's positive. So it's positive √2/2. And then the reciprocal of -1 is negative. Or 1/-1. All right, for questions on this? Questions on knowing where to find the angle? Okay. For number two, you're splitting up your pies into sixes. So I went 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so I just have to go 11 multiples of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I end up with that. Okay. And then there was a question on how do I know if it's the 1/2 or the √3/2 first? Okay. There's multiple ways to answer it. So one answer that I was giving the student was for pi/3 and pi/6. In terms of values of numbers, 1/2, think of it as the square root of 1/2, is smaller than √3/2. So numerically, this is a bigger number. So if I want to figure out which of these two angles has the larger x coordinate, at this point, at this angle here, x is about this long, versus for pi/6, x is a longer value. So this one should have the pi/3 first. Okay. So I do the same thing here. Which has a longer x value, this angle, or if I was to use the pi/3 version here. Notice that this one's going to be longer, so it'll be pi/3/2. Or another way of thinking about that, this has a reference angle of pi/6. So if I was to draw pi/6 right here, that's directly below this point. So it would have the same coordinates, but y would be negative. Okay. Let's see, help me out here. Sine of theta here, sine of your angle would be -1/2, cosine positive √3/2. Tangents are gonna be a little nastier. Let me show some of that work. Hold on. -1/2, which is your y, over √3/2. So what did you guys really do? You multiply it by the reciprocal, which is 2 over √3. The 2's canceled. So you ended up with -1 over √3. And then you got a freaking rational. Yeah, so that becomes -√3/3. And then for your reciprocal functions, the reciprocal 1/2, -1/2, -2. The reciprocal of this guy, let's see, let's be careful with that one. 2 √3, but you got to rationalize. 2 √3/3. And then this guy, when you do the reciprocal of tangent, is going to be -3 over √3, rationalize again. I know, it's a lot of rationalizing. Over 3. Okay. Whew. The calculator will, if you put this on the calculator, cotangent of 11 pi/6, it'll spit out a negative decimal, but that's the decimal that it's spitting out. Question and a question.
Is that not simple?
It does.
Oh, shit, it does. -√3. Yeah, thank you. Was that your, yeah, thank you. Okay, guys. Whew. Question.
It is positive. He just wrote-
Oh, I'm sorry. I got fancy with my square root symbol. Yeah. I put like a negative by accident. I was like, wait, no. So thank you. Yeah, you're right. Okay, guys, so let's take a break. When you come back, I'm gonna have you fill in a unit circle. Some of you guys already have one. Okay, that's fine. But some of you don't, and it's gonna be very helpful because as you can tell, as long as you know the coordinates, you can calculate the trig functions really fast. And then we're gonna do a little bit of application problems, some word problems with trig. Okay? But let's take a break because it's hella hot.
Oh, is that one the 6.2?
That's the 6.2, yeah. So come back at 2:05. Your iPad's dying? Here, charge it. Well, we have a break. Yeah. Do it. Well, let's label them as positive angles.
Okay.
Yeah, so this will be 90 plus another 90. 180 plus another 90 and so on.
Oh,
Yeah,
this the next one would be 270 and negative 9. Oh, we got that.
it would be 270 positive. That's positive and correct. Which is the same location as negative 9. Did anybody not get the unit circle sheet?
It sounds good here on this one. Okay, let's see here and then see everything.
Correct, yeah, that's why there's two there. That's 360, which is also 0. There's only these values and the gradient. If they're really going to do it, use a 5 and 6 gradient books. One, two requirements like that. Correct.
It makes it that's not bad.
Those little radiants. Yeah. And the next to it, that would be-
You finished, try to help out a classmate. The document, the sheet will be for the second part of class. Okay? We're not there yet. Leave it back. No, it's not coming. Well, here's pi. Pi is 90 degrees. Remember, you can always convert it. So
All the time. Or is it?
correct. Yeah, you can always convert it. You got a few more minutes. If you're not finished with your unit circle, it's okay. Just finish it on your own. Yeah, so each of these. Erasing the board. Okay, guys, unfortunately, we have to move on. We have an hour left before class is over. It's okay if it's not done. You can fill it out after class on your own time. Okay. So what we're gonna do now is we're going to switch from using what we just did on knowing how to evaluate trig functions at all these different angles and bring in right triangle applications. Okay. So let's see how that's gonna look. Let me make sure I'm recording. Yep. All right, so section 6.2, right triangle application. And let's see how this is going to connect to what we just did. So let's go off of what we know. We have our unit circle that you just filled out. Okay. We discussed how, oh, it's a horrible circle. But I just can't. The math in me is killing me. Let me do a little. Okay, so we rotate our radius by a particular angle theta. Okay. Where we define sine and cosine to be these x and y coordinates on the unit circle. And as I rotate it, as we've been doing, we drop down this vertical line, and then it gives me this nice little right triangle. Okay. The radius of this right triangle, sorry, the radius of the circle is 1, so this length is 1. What is the side opposite of the right angle called? Hypotenuse. So our hypotenuse is of length 1. This length here corresponds to the distance of the x coordinate. And this vertical length corresponds to the distance of our y coordinate. Okay. So then what we're going to do is we're going to use the fact that we know the dimensions of this small triangle, and we're going to bring it up into all kinds of different right triangles. Okay. So we're going to bring it into all the different types of right triangles here. And then I have my little guy here. I have my little right triangle with 1. Here's theta. Here's x and here's y. And then I can consider another larger right triangle like this, so that it's a right triangle like this one, and this angle is again theta. Okay. So it's larger, it's bigger. Okay. Again, what is this side called? Hypotenuse. So I'm going to call it HYP. Yeah, you know me. And then there's the opposite side here of your angle. I'm going to call it the OPP. And then this side touching the angle, ADJ for adjacent, okay? But here's the beauty, that fuses this theory with right triangle theory. In geometry, when two angles have congruent angles, or the same angle, okay, on the same side, they're not congruent triangles, they're what's called similar triangles. Kind of familiar?
Yeah.
Geometry back in those beautiful days. Okay, so there's a little, you don't put equal, it's like a little squiggly symbol here, and this stands for, these are similar triangles.
So the top one's squiggly and the bottom one's straight.
Yes.
I believe so, yes, or I think some textbooks use both of them like that. For equivalence kind of thing. Okay. Wait, what's useful about similar triangles is they're called, their sides are proportional. What does that mean? That means that if I divide this hypotenuse over this length, that ratio should be the same thing as dividing this longer hypotenuse by this longer adjacency. Okay, that's what's beautiful about similar triangles. So if I do my adjacent side on the big triangle divided by the hypotenuse side, this ratio should be equal to the adjacent side of the smaller right triangle over the hypotenuse of the smaller right triangle. And so what's x over 1? X. But this x is this x. And that's what we've been calling cosine of theta. Okay. That's what we've been calling cosine of theta. And so here it's showing us that for a bigger right triangle where the hypotenuse is bigger than 1, I can also find the cosine of this angle will be the same thing as dividing the adjacent side over its hypotenuse. Okay? And then we do the same thing for sine. Sine is the y, right? So in this case, I'm going to do opposite over the hypotenuse on the big triangle. That should be the same thing as the opposite side of the angle, which is y over its hypotenuse. And that's just y, but by definition, this is what we're calling sine of theta. And then the last one is going to be opposite over adjacent. So if I do the opposite over the adjacent side of this bigger triangle, because it's similar to this little guy, that ratio needs to be equal to this opposite over that adjacent, which is this y over this x, which what did we define y over x to be on the unit circle? Tangent theta. And that's how these two worlds fuse with each other, okay? Here comes a famous thing that you guys use or learned in trig, SOHCAHTOA, right? I hope I wrote in the correct.
You wrote it wrong.
I wrote it right?
Sine, cosine.
Oh, crap. Hold on. Okay, yeah, sorry. Okay, I fucked up. I was supposed to write this one first. So stands for sine is equal to opposite over hypotenuse. Cosine equals adjacent over hypotenuse, and then TOA. Tangent is opposite. CASOTOA.
That's another way to say it. Yeah.
It's a different.
Still accurate.
Yes. And then you still will do the same thing with secant, cosecant, and cotangent. It's just the reciprocal of these. So it turns out to be the reciprocal of these.
So it's so.
Huh?
Yeah, maybe I don't have to.
Yeah.
Calm down.
Would that mean you would do like show?
What did that have to do?
Show.
For the reciprocals?
Yeah.
Well, secant starts with an S, so we can't use that, yeah. You just have to know that it's the reciprocal of this, so it would be hypotenuse over adjacent.
The thing is where the cosecant is for,
I agree.
You just have to remember it because it's weird.
that's true.
Yeah.
It's like there's one co in every single like pair, so it's like, you don't remember.
So like math isn't supposed to make sense. So I get that.
Sometimes, yeah, the definitions kind of don't follow through all the way. Okay, let's super quick review. Let's find sine, cosine, and tangent for a bigger right triangle. Where, let's say this side here is 4, and this side here is 3. So it's a right triangle, so the Pythagorean theorem should work. So let's say I don't know this side. Maybe you already know, it's okay. I use the Pythagorean theorem. That's my hypotenuse. So it should be 4 squared. This 3 squared should equal my hypotenuse squared. 4 squared is
I'm 16.
16. Plus 9. That's 25. Square root both sides. Plus or minus 5, but here C represents a length, distance. So it's gonna have to be 5. Okay. Now, does this triangle live in the unit circle?
Yeah.
No, because that hypotenuse is length 5, right? But it can only be length 1 if it's on the unit circle. So it's like this bigger triangle that's sticking in. Kind of what's happening. But because it's a similar right triangle, the one that will live in the unit circle, we can use what we just defined here to still find cosine, sine, and tangent. So then sine here, or I guess let me follow the same order that I did here. Cosine of that angle would be cosine is adjacent, so that's 4 over its hypotenuse. Sine opposite. That's going to be 3 over 5. And then finally, you would have tangent be 3 over 4.
And then the triangle that you use, a root 2a and, like the 3 parts, is that when you're just trying to find the, angles? Or do you use that when you're trying to find a side as well?
Say it again.
Like the one, the right triangle rule that has 2a.
Oh, those are, yeah, those are gonna be, yeah, I think I know what you're talking about. So yeah, so you're gonna use the knowledge of the special angles that we discussed. So there's special triangles that have to do with these angles that we just found. So like, if I have 30 and 60 here, right? And I wanted to figure out those lengths. I guess that I'm just gonna label what I think you're asking.
Yeah,
You're saying if the hypotenuse is 2a, okay? What should cosine of 30 degrees be? Knowing what we just discussed, cosine pi over 6. If you look at your unit circle, what's cosine of pi over 6? Remember, 30 degrees is pi over 6 radians. Root 3 over 2, right? And so you guys learn, Alex, I think you're referring to your past trig class, right? That there's like this root 3 labeling of angles.
Or a root 2.
Or a root, that's a different one.
Okay.
So in this case here, let's see. Does this match? Cosine is adjacent over hypotenuse. So it better equal that. Let's see, cosine of 30 degrees is adjacent root 3a over 2a. the a's cancel √3/2. And so if you're wondering what Alexa was asking, she's saying that when you have a special triangle called a 30, 60, 90 triangle, whatever the length of the short side is, you double that to give you the length of the hypotenuse. And then you multiply it by √3 to give you the length of the other side. I think that's what you're referring to, right?
Yeah, but the other one was the A√2, which is that
That's the
also?
45.
That's 45, 45.
That one's 45, 45. Yeah, so this one's a 45, 45, 90. And that one, we know cosine of 45 has to be cosine of pi/4, which is √2/2. And so for this one, I guess there's different ways to label it as well. But if this is A, I think the way they label it is different. This is A and this is A because this is the same angle, same side, and this is going to be √2A.
Okay, that makes sense.
And let's check. Cosine of 45 is adjacent over the hypotenuse. So the a's cancel. Rationalize the denominator. And then you guys get your famous √2/2. So the thing is that trig, there's two ways to teach it. There's like the right triangle approach, and then there's a unit circle approach.
But they're all connected.
But they're all connected through this. These are used for applications because in applications you use triangles a lot. But for calculus, when it comes to like functions and domains and all that, the unit circle stuff is used more. So it's a little bit of both, depending on, and that's why I wanted to go over applications so you guys can see the other side. Go on.
Are you gonna teach the trade like doesn't involve right triangles? Like just regular triangles?
I'm gonna do a little bit of both. We'll do a little bit of both, but I think I emphasize this more because this is where the students struggle the most. Especially when we get to the graphs of the trig functions. Okay. So. From our definitions here, or actually, yeah. From our definitions here of our Kasawa Hoa, we're gonna figure out how to use this with applications, real world applications, okay? And we're gonna do 3 examples. We're gonna do one together, then you're gonna do 2 that are on the back of your handout. Those are literally problems from a calculus class that use trig. It's just you're not doing any calculus, okay? All right, so well, let's take a look at an application example. I'm only going to write a word problem today once, okay? So let's in this example, it's the famous ladder leaning on a wall.
Oh.
So there's a 10-foot ladder.
Oh.
Sound familiar?
Well,
Leaning against.
house.
I'm gonna, the textbook said building, so I'll keep it
Oh,
building.
It's a funny building.
Against PVC building, the math building, okay,
This is my setting, you know?
against a building. Forming a 60-degree. A 60-degree angle. With the ground. Yeah. And so our question is, how high up the side of the building does the ladder reach? So 10-foot ladder laying against, a building forming a 60-degree angle with the ground. How high up the side of the building does the ladder reach? And so let's just try to paint a picture here, okay, and then I'm gonna give you guys the. I'll tell you where the calculus will come in when you guys see this problem again. But here's the ground. Here's the building. Put some windows in them. Big old building. And a nice little door. Okay. And then you have your ladder leaning. Right here, there's your ladder. Where is the 60-degree angle? Up here or down here?
Right there.
It says it's forming a 60-degree angle with the ground
So the bottom right.
here, because that's the ground right there, okay? So that part, be careful. What do we know? What information do we know about, notice we formed a right triangle. Do we know anything about the sides of this right triangle here?
The hypotenuse is 10.
The hypotenuse is 10 because that's the ladder, right? It's 10 feet. Okay, and so what are we being asked to find? How far the ladder is from the building or how high it's up on the building? How high it is, right? So that's what we don't know. Let's give that a variable. Let's call that B. Okay, because that's what we're being asked to find. So it says, how high up the side of the building does the ladder reach? Anytime there's a question asking you for an unknown, that's usually your variable. Okay. So if I knew this other side, I can use Pythagorean theorem, right? Figure it out, but I don't, so I need to use trig. Okay. And so, yeah, so those triangles are gonna come into play. Now I have this side that I don't know. I have this side, this hypotenuse, and this angle. So which trig functions can I use? Which three? Corresponds to this side and this side, and this angle. Opposite. So that's gonna be opposite over hypotenuse. So sine, right? So we're gonna use sine. The sine of 60 degrees is gonna be B over 10.
Now you just multiply 10.
And so we're solving for B. Yeah, so we have to solve for B. Solve for B. Okay. What did you say to do?
Multiply 10.
Multiply both sides by 10. 10. 10. So we get 10 times sine of 60 degrees equals B. And so now what you're gonna do is now you're gonna apply the knowledge with the unit circle stuff. And ask yourself, what is sine of 60 degrees? So let's look at our unit circle. Sine, what is it? √3 over 2. So then you go ahead and you plug that in. And then you multiply it out with 10. Okay? So this reduces and 2 goes into 10 5 times. So B is gonna be 5√3, which is around 8.66. What are the units? Question.
Why is it √3 over 2 and not 1 over 2?
Let me see how you label it.
It's supposed to be.
Uh, it's sine, so it's the y coordinate.
Okay.
Yeah. It's size. Okay. Cool. Yeah. Question.
So we could have also solved it using the special triangle thing.
You could have also solved it using this special triangle here, and it would still would have given you √3 over 2. Question?
So, if we are given like that 8.66 feet, and we are asked like, what is that in radians? Is there a way to know, or is that where you multiply by 180, or you gotta convert it back into radians?
So is B representing an angle or a distance?
It's a distance.
Distance. So you don't turn it into radians because
Oh,
radians
in
is for
general.
angle.
in general, because that was part of the homework problems too, like the concept of having, like infrastructure questions, you have, like they. ask you to
Oh,
convert
I
it to
get you.
feet. So like, how do you convert backwards into radians?
on the homework that you did earlier, you had to convert to radians because you weren't multiplying the angle, you're multiplying the angle with the distance, but here you're taking sine of the angle.
Yeah.
So that's why it doesn't matter if you use sine, radians or degrees.
Okay.
The sine of it will still be the same thing. Versus like arc length, I think is what you're
Yeah.
referring to, that's, I think R times theta. Theta has to be in radians, it has to be,
Got it.
but you're not involving trig yet in this problem.
Yeah.
So here, yeah, you can leave it at 60.
It was kind of an unrelated homework question.
It's okay, it's okay. Also, be very careful that your calculator is in degree mode. Okay? Okay, little foreshadow what a calculus problem is gonna ask you to do, okay? I'm not gonna have you do it, but basically in calculus, you're gonna study things changing, so you use rates a lot. So this problem's common in calculus. It'll say, there's a 10-foot ladder leaning on the building, where the tip of the bottom of the ladder slides away 2 feet per minute. How fast is the bottom of the ladder? How fast is the top of the ladder sliding down? That's what I'll ask. But what you'll need to do is you'll need to make this setup. And then you use all the calculus stuff to help you answer the rest of the question. But it's the students that when I'm in their, when they're with me, this is the part they're not getting how to do yet. So that's why I gotta make sure I bring this in good time. Okay? But yeah, so that's what a calc question will look like. Okay, so if you guys turn the back of your unit circle, I have 2 application problems. Similar as this one, you're gonna use trig to help you find missing links, given some angles. So let me have you guys work with your groups. I'll go around and help you. Please check in with your groups if you finished the first problem. Label things as much as you can. I included some pictures there for you. Practice these out. It'll be helpful if you guys can determine the right triangle that you're supposed to use and label that one, okay? In your picture.
Yeah, so you're going to bring this here and let's see a rope attaches to the bow of the boat. It's this way. And passes through a pulley on the bottom. It's this one. That is this, then it says that pulley is 1 meter higher than the bow of the boat. What do you think that means? This one? Yeah, where is that 1 meter? What it's referring to? No, so it's saying that this thing, this, oops, it's saying that the pulley, this pulley thing right here, this is 1 meter higher
Oh, like in
Then
terms
the
of,
bow of, yeah,
like, okay,
yeah.
okay.
So where is that 1 meter? How would you draw a picture where that 1 meter is?
Mm. But in terms of triangle.
Mm-hmm. Mm-hmm. No, not quite, not that one.
But I
So,
know.
so imagine this is your eyesight, right? Is the bow of the boat,
Mhm,
right? And then the pulley is up there.
mhm.
So you see my line of sight is straight.
Yeah.
And so if this thing, if this is just a horizontal line straight, that's 1 meter up. Above it.
So it would be.
Exactly like that,
mm,
but not all the way up here, just up here.
Okay,
Yeah.
and then it goes back.
Yeah, right there, that little triangle.
Oh, okay.
See it?
So, sorry, no, you're good.
1 meter, and then the question says, what is the length of curve?
So did I put the 6 on the right place?
No, you didn't. So
Would it be on the bottom?
it says, what is the length of the rope when the rope and the dock? Where's the rope? Where's the dock? Right there. So where's that 60 degrees gonna be? Well, it has to be inside the triangle.
So not a measurement. It would be like a measurement. Like, you don't know how big, I think.
Not quite. So you have this triangle, right? So let's say I want this. 60 has to be, see right here, this is where you have 90. That's because that's straight down. So where would this 50 degree be so that it's between the rope and the dock? Well, this is between the rope. Is this the dock or is this the dock?
Oh, that's. So I want to.
No, that's the 90 degree.
You just go with the one.
No, it's right there. That's the 60 degree. Yeah.
Yeah, that definitely does.
It's now AT and BPS.
How easy it was, like 10 with us.
Confirm using Chris.
So we're using like the one.
Since we're looking for the. On this.
Yeah.
So once we have, I just have to be doing, because the opposite from angle is one. And the I just have to one, and the one you're looking for is the hypotenuse.
Which is.
One.
Length.
Very, yeah.
Okay. So then. So if it's an over hypotenuse. Yeah.
This is the journey. This is the high part.
Yeah.
Oh, I. And then multiply 45. I wouldn't drag, but. I can fast. Okay, well, then you're right, right, but.
I mean, it's a.
opposite from the angle you're using, or do you do opposite from the right angle?
I think it's opposite.
Is it opposite of the right angle? Oh. Wait, no, the opposite of the right angle in that case, you see the hypotenuse, so no. No, we close sectarians, right?
Yeah.
It's close for the first one.
Yeah, so it's
So we're all, we're kind of
like the one across from the
the
mountain.
one here. Is that the-
Yeah.
And it's 60 is in the top right.
So I'm trying to, sort of like telling you, it's either like literally my one or something or something. There would be some point where
The opposite would be where you both side. Because the opposite means there's not.
So this would be a reason.
Yeah.
Okay.
No, there's one on the bottom, is the opposite.
Opposite, right?
See, because you look from a 60. No, let's see. This is your opposite.
Oh.
Because opposite is 60. Yeah.
So I have. Right. Basically. Yeah. Yeah. But is the back like?
It's not trying to do it. It's very. But I know if you could have not like see.
This is like X, right?
Yeah.
Even like.
And then.
Yeah, I think that's right. Yeah.
You divide by the.
Close.
So
And then the close in this case would be 1/2, right?
Yeah.
Yeah, the one show. They've really done some. There.
That's closer. X.
Well, that's
The second one.
Yes.
So would it just be equals one? Or would it
Would you
be-
know? Would you have to be 1/2 equals 1/2, which would then you would have to divide by 1/2. Or yes.
So I'm like, yeah, right? Basically, there.
So it's, and then you do 1 times 1/2. There. Wait, you got rid of the 1/b. That one.
Oh, okay. So it would just be,
You do 1 times. Or you do x. Wait. Where did I put mine? Wait, how does my x get over here? Oh, wait, I multiplied both sides times.
oh,
Oh, yeah, because I don't know, I multiplied both sides of that sheet to get rid of the.
oh.
You like, I guess.
Okay, so then it would be close to 6. 1.
Yeah,
Would that make sense? Though?
no, but then b is on the other side.
No.
And then you, do the times 1/2. Because you have 1/2.
So then that'll be 2.
Yeah. It's divide you divide 1 by 1/2, which is 2, right? I think.
If we were to be using.
Don't complain, I haven't eaten.
This is the date, that's all.
You are copy guy.
That's all.
I've been up since 40.
Basis. Yeah.
Why?
So-
You can get the green one. But this one.
And that's someone.
No, I got a little.
It's not, okay, there's that one. Good job. Fine. Okay. Cameras.
I wonder how many
It's the sign. Yes. But now. Smaller triangle. And so this is 1 meter.
I just remember, yeah.
Because you're given. Yes. Pardon. Which is one of the right.
Yeah. Question about
We are given the thing that's. And a hypotenuse tomorrow, so we have 1 over.
It was.
So now it's isolated speed. Divide by
Where you describe and then.
Like if the company.
They're not the plus or minus. I put it. See, I see.
Yes.
I'm gonna go.
I use the sign, but that's really. It just matters what you plug in there.
Thank you.
So which one you.
No. Yeah, everyone, you know. Yeah, so let's say you didn't know this, right? Because that's what you look at, everyone. This is the one you're looking for. You don't- you want to go there.
He said, actually,
Well,
I
start
told
over.
him, I think the way he dressed this.
That's.
Sorry.
I think you have that like.
All you know. It's good. Like, yes, I don't know.
Yeah.
I was gonna say.
So when I met him, I was like, you're getting with you looked at me.
Yeah, I'm not really.
And that's. It's. I think the. Wasn't.
I got.
I'm sorry. It's sorry. We do it for all the money. Yeah.
What?
No, we're gonna do now. That is one, that is one.
Craig?
We do that motion.
This is Craig, you good?
It's not, oh, he doesn't do it. That one knows. Oh, he didn't know there was going to be. Like. It started on Thursday. The last day before spin.
Is this it? We got a little bit more. but pretty much we're kind of done.
Yeah, I really thought there was almost 2 weeks ago, we might try to say,
All right, guys, we're gonna move on. I'll post the solutions to the handouts. I'll post the solutions. The last thing I want to do, it'll be fairly quick. Is basically what would we do if this angle was 70 degrees? Okay. How would we figure that out? If this was, all this changed to a 70, and then here we're stuck.
Convert it to radian.
Even if we
Or-
convert it to
yeah.
radians, it
We
would still be.
wouldn't need to, we just take 90 and 70. And 80.
Yeah,
Can we do that?
we can do that, yeah, and it's
Is the calculator?
this right here, this, you can't just separate it into things like that. With a big ol' identity for that. Okay, yeah, it's not that simple, we can't do that. That'd be super cool, we can't. So. For most applications, we need to know how to evaluate trig functions at any angle. If we were in the 50s, that would be really hard. Okay, I don't even know, maybe even before that. So let me give you an example of kind of how you can think about it, but then eventually, yes, we're gonna use a calculator. But let me just show you real fast. So let's say we wanted to figure out sine of 70 and let me pick another random angle, which I'm gonna do cosine of 152 degrees. Okay. How are these angles or how are these values found? Again, back to the unit circle. 70 would be somewhere here. Okay. 70 would be somewhere here. And 152 is very close to 180, so it'd be like, let's say somewhere here. This is 152. Okay. And so we can kind of estimate what it might be. Sine is supposed to be equal to the y coordinate of this point when you rotate the radius of 170 degrees, right? So if I look at the y coordinate, is it bigger? Like if I was to round up the y coordinate, right? It's like around right here. It's very close to 1. What do you guys, if I asked you guys to guess sine to 70 degrees, what do you think would be the value of this y coordinate? Bigger than a half?
Yeah.
Like 0.8-ish, 0.9-ish, right? Okay. And so yes, back then, what you would have to do is you have to get the unit circle, and then you can use this to help you evaluate that, approximate it, right? Now we have calculators that will help us do that. So go ahead and go in degree mode. And let's see, what's sine of 70 degrees? 0.93? 94, okay. Which makes sense to what we were saying. It should be something very close to 1, right? Yeah.
So if you like sine of 75 degrees, to find that, you can just find the sine of 45 degrees and 30 or 30 degrees, and then add them.
That's what this is.
But I swear we learned that last semester. Like if you break up the degree into 2.
It could eventually help you find that, but it's not as easy as just adding the results. There's a big trig identity. But yes, you're right. You can use 35 or 40 or 75. But then you would need a big trig. You don't just do sine of that and add those results. It's more complicated.
Is that how the calculator does it like all internally?
It uses, no, it uses something even more powerful that you will probably learn in calculus too. It uses this infinite polynomial that is somehow equivalent to sine of 7. Okay. My guess is that's polynomials are easy to do. Okay, let's see. Cosine of 152 before we plug it in the calculator. Cosine is supposed to be this x coordinate here, and -1 is here. So what do you guys think approximately cosine of this angle will be? Close to -1, like -0.8 or something, okay? And it's gonna be 88, there you go. Okay. So, basically, yeah, you'll be using your calculator, but I just kind of want you to understand these numbers really have life in the unit circle. And you gotta be careful, like some people get confused, why did I get a negative? Well, because you're on this quadrant or the English. Okay,
And then if you put it back into the calculator, the inverse, it would be 151.6.
oh, if you do the inverse of it, yeah. So if I was to do this problem, and this angle was 70 degrees, I would get to this step right here. That you did. But now instead of plugging in √3/2, I would go on my calculator. And plug in approximately this value. And then that would give me approximately, B is approximately 9.4 feet. You would just use your calculator for that, but just be careful that you're not in degrees. Sorry, in radians. Like make sure you're in the correct degree unit. Okay? That's it. I'll stay around if you guys have questions.
Thank you for.